So our next speaker, we're staying on the ground segment. We're going to talk about the security implementations of the Yamcs mission control. So today we have here Alexander Balgavy, who will talk to us through his presentation. He is a software engineer at Space Application Services, where he works on the management infrastructure for the Columbus module of the ISS, as well as general development and security implementations for the mission control software that they develop.
Well, thank you very much for the introduction. Good afternoon, everyone. Let's see, how can we switch the slides here? I just click next on this and that goes? Okay, perfect. Yep, so hi everyone. I'm Alexander Balgavy and I'll tell you a little bit about security and Yamcs mission control and how we approach it. Perhaps this might be some inspiration for other software, or it might just be an interesting case study of how we do it. Anyway, this is what I'm going to talk about. So I'll start with a bit of an introduction. I'll introduce myself, I'll introduce the company, and then I'll introduce Yamcs as well. And then I'll go into how we approach security. So I'll talk about how we approach security in development, but then also in actual usage of the software. And then I'll finish off with some concluding remarks. So me, I am a software engineer at Space Application Services. I am a Yamcs developer, so I work on the source code for Yamcs. I'm also a Yamcs instructor, so I do the online and the on-site training. Space Application Services, we are a Belgian company. So we're headquartered in Brussels, but we also have an office in the Netherlands, so that's close to the ESA site, ESTEC. And we also have a subsidiary in Houston in the US, so that's Aerospace Applications North America. So where do we go as Space Application Services? Sort of all over the place. We do a lot of work in low Earth orbit, so for one, we own and we operate the IceCube service, which is a commercial platform for science experiments on the ISS. But we also have hardware and software projects for the moon, and we also have some terrestrial projects. So what is Yamcs? Yamcs is a software product. It is a mission control framework. Imagine you have a spacecraft. You want to see what data it's sending down. You want to be able to send commands up as well. This is what Yamcs lets you do. It lets you watch the telemetry coming in. It lets you send commands up. And that's sort of at the basic level, but there are a lot more features. You can also schedule commands. In the end, you can run essentially automated mission operations using Yamcs. So that's a basic overview. Here you have, for example, some data that Yamcs processed on the ground segment. So this is the first full image of the Earth that Yamcs processed. You see also some organizations that are using Yamcs. So Yamcs is a mission control framework. We call it a framework because it is very easily extensible. You can easily add extensions on top of it for a specific mission. You can configure it. So that's a large advantage. It is free and open source software. It's licensed under the AGPL. The core entirely is public. There's one server that provides all the functions that you would need. And there are also additional applications, and there's an API. So in case you need more extensibility, in case you need to integrate with existing systems, that's entirely possible there. The development of Yamcs is driven by our customers and by our users. So if somebody needs a feature, they can come talk to us, and then we can implement it in there. Or because it's open source, they can open a pull request as well. And they can integrate that code in there. Of course, we do commercialize it, and we do that by providing training and other support. And we also provide commercial licenses. And there is also the possibility for a managed cloud deployment. So let's say you don't want to run your own server. You don't want to manage your own Yamcs installation. You just say, I want to use Yamcs. And you say, I want to use these ground stations to connect to my spacecraft. Then you can have an entirely managed cloud deployment of Yamcs. So in short, that's what it is. Types of systems that it can control. There are a lot of options. There's payloads. You might be familiar with ACES, the Atomic Clock Ensemble in space. Yamcs was used for that. But there is a lot of different types of payloads and free-flying spacecraft and vehicles that have been controlled and monitored by Yamcs. And we have different types of users, ranging from hobby and individual users, universities, academic researchers, all the way to institutional users like NASA, ESA, MBRC. So that's an overview. That's an introduction of what Yamcs is. It is a mission control framework. It's a software product. How do we approach security in Yamcs? Let's start with development. So I think I'm sort of preaching to the choir here when I say that open source software has huge security advantages because of the transparency, because of the community around it. So if everybody can see what's going on in the code, if everybody can see the development, there's possibilities for collaborative audits, there's possibilities for review, there's much lower chance that there will be some hidden malicious code in there because it is easy to review it. We can also apply some community-led and community-driven best practices for this, and there is more transparency, there's more community engagement, such as this conference here. So the way it works in Yamcs is all the code for Yamcs is in this public repository. Anybody can look at that, the development is in public, all the releases are in public, everything is there. Of course, some customers might not want their data to be public. They don't want their configuration to be there. And so for that, we have some private repositories where we include any mission-specific extensions, where we include any mission-specific configuration. But in the end, the Yamcs that everybody is using is this public one. So in the main software, there is no difference. And then everybody benefits from the open source collaboration. We have some pipelines, of course, and these are also entirely visible in the public repository, so everybody can see the quality gates that the code goes through before every release, what kind of tests are there, what kind of analysis is done. Everybody can see if all of the things pass or not, if there might be an issue. And then we have something similar for our private repositories with potentially some deployment depending on the customer. So in terms of the security part of the development process, there are a lot of external assessments that happen. These can be automated external analyses. So for example, some dependency analyses looking at which dependencies or dependency versions might be vulnerable. And you can see here an example of some of these dependency updates and upgrades because of these issues. There are also audits, so there can be mandated audits, for example, for our internal processes, but also from companies such as T-Logos or, for example, for the ISS ground segment audits, because Yamcs is used in the ISS ground segment. We need this NIST Special Publication 853 to be regularly, periodically audited in the infrastructure, the code, the development processes, but most importantly as well is this open source engagement. So there are community audits. There have been many in the past, and I'm sure there will be in the future as well, from academic researchers, but from companies as well. So for example, one of these audits was done by Vision Space. We had Milenko Starczyk give a talk earlier down in the master room where he was describing how they do audits on software and they have security analyses of software. They did an analysis on our software as well, on Yamcs, and they found some pretty important CVEs. So we're always thankful when members of the community do these sorts of audits because this improves the code base and the experience for everybody that's using Yamcs. And these vulnerabilities were disclosed to us properly and they were fixed in the next Yamcs version. And actually, this led to something fun as well. So Yamcs was used in a CTF at DEF CON 33. This was these vulnerabilities that were discovered before. It was in the Starpwn CTF of 2025 that was hosted by Aerospace Village. So not only is there a benefit for the quality of the code and the security of the code, but then you also have these interesting events that happen because of it. And then, of course, that puts more eyes and more interest in the project. And hopefully more people that will want to take a look at it in the future and do some audits. So we've looked at how we approach security in our development process. What does Yamcs offer in terms of security for actual usage? Let's begin with authentication and authorization. So Yamcs can integrate with any of your existing authentication systems. Let's say you have an LDAP set up in your company or in your infrastructure. Let's say you're using Kerberos or you're using OpenID Connect. This can all be integrated easily with Yamcs, so there's no need to create any specific or any bespoke system for this, any authentication approach. This all integrates well with Yamcs. and there's role-based access control. So you can really say like which roles can, down to the individual parameters, like telemetry data that's coming down, which roles can look at which parts of the system. Now there's of course also security and communication. If you're getting telemetry from a satellite, or if you're sending commands, you want that communication to be secure. You don't want to fall victim to eavesdropping or man-in-the-middle attacks, especially if you're sending commands to satellites. In the past, sort of the only option was external encryption. What I mean by that is you treat Yamcs as a communication black box. You encrypt outside of it, send encrypted data through, and then decrypt outside of it. But recently, in let's say the last year, we added support for CCSDS Space Data Link Security, for SDLS. And now there's a built-in implementation that offers authenticated encryption. So the thing is, this is also easy to extend. So because it's open source, anybody, if they need an additional version of encryption, if they need, let's say, a FIPS certified library, some sort of other cryptographic algorithms, it's very easy to implement this on top. Or alternatively, they can ask us and we can agree to implement this in there. So this is for communication security. And the nice thing is, if you have these sorts of standards that you're using, if it's open source, it's very easy to then add additions that integrate and improve interoperability with other existing systems. So one example here is CYSAT Arca SatLink Space, which also has SDLS implemented. And we recently did some integration tests with them, and we confirmed that our implementations are entirely compatible. So that's another nice benefit, that now you can kind of mix and match which parts of the different products you use, and you don't have to completely replace anything, and you could choose what you prefer to do encrypted communication without compromising the security of your communications. Yeah, so that was it. I would say that our aim with Yamcs is to be the most secure open source mission control framework. That's a high ambition, of course, and security is more of a path than an end goal. Nothing is ever really 100% secure, but we strive to go there, and we do so through the methods that I described. So one of our big benefits is that it's open source, and we really like this development in public, so we make it completely transparent to everybody. And we also provide these security features that I described for the operational system to make sure that your communication is secure, and also you can integrate your authentication and authorization with what you already have. And of course, we address the bug reports and any security audits in public, so everybody can see the results of those and see what gets integrated then back into the main code base. So thank you very much for listening. On the left side here, you have a QR code to our website. On the right, you have a QR code with my email. It's also written there underneath. Yeah, we have some information. Here's our managing director's contact in Europe and our president for our subsidiary in the US. Yeah, thank you for your time. And if you have any questions, I'd be happy to answer them.
Thank you very much for this very interesting presentation. Do we have any questions from the audience? Yes.
Do you have a process to ensure the key confidentiality at injection time into the Yamcs control center?
For key confidentiality, do you mean for SDLS or for?
Yes, for the SDLS keys. As long as they are inside the control center, I assume that they are in a ciphered container, so they are safe. But for the injection, there might be logs somewhere which could be able to retrieve the keys. So do you have a specific process to ensure that there is no such things?
We don't really have a way to inject keys at the moment into the system, so we don't have SDLS extended procedures, but we have the basic procedures, which you already have the key configured on the ground and then also on the flight. So there's no way to sort of insert the key into the system.
Any other questions? I had a quick question, otherwise. That is, do you also, you say that, of course, the project is open source, you deploy it for certain clients. Does that mean that you host it yourself as well for clients, the mission control center software?
Yes, we can also do cloud hosting. So we host it, well, I don't know if on-premises is technically the right term because it's a little bit down the road. So it's not the exact same address as the headquarters, but yes, we do host it ourselves. So this is this kind of managed installation of Yamcs where then we do everything and the customer will just say, I want to use Yamcs and these are the ground stations or the ground station providers that I want to use. And then, yeah, then we do the hosting, we do the configuration, and we give them an interface through which they can interact with it.
And I can imagine that there's also a few security or cybersecurity implementations that you could implement for the self-hosted version.
Yes, indeed. When we have the whole cloud system, then we are talking about the security of the cloud system as a whole. And indeed, there are security controls there that we have implemented that for such a system are absolutely necessary.
Perfect. Okay, in that case, I would like to give one last round of applause for our speaker.
Thank you.